All right, 12 is asking, is there ever an interval that the slope of the function has to be equal to 2? Well, slope, when we don't have the actual function and we only have the function values, is just old school change in y over change in x. So when I do change in y here, I'd have 0 minus 8 is negative 8 over change in x, 4. My slope here would be negative 2, and they want it to be positive 2. So I'm just going to continue checking intervals. Change in y, 2 minus 0 is 2. Over change in x, 8 minus 4 is 4. That slope is 1/2. Change in y here would be 8 over the change in y here would be 4. 8 over 4 is 2. So what that means is that from the interval from 8 to 12, the average slope there was 2. So there has to be a time anywhere in between or from 8 to 12 that the slope is 2. Okay, everybody, you're going to skip 13 because that's L'Hopital's rule. We will get to that when we come back from school. 14 kind of ties into 8.1 like we were talking about right before we had to go on our COVID break. So they tell us we've got acceleration and they want to know the position. So if they gave me f double prime, I really need to get to f. And that means I need to integrate the function twice. So if I integrate acceleration, I'm going to get velocity. So I'm going to integrate 12t. And when I do that, I'm going to have 12t to the second over 2 plus c. And that simplifies to be 6t squared plus c. But the piece of information that they tell us is at time t equals 0, the velocity is 2. So when t is 0, don't forget what we're solving for here is my velocity. My velocity is the integral of 12t, or the integral of acceleration. So if when t is 0, the velocity has to be 2. So if t is 0, what does my constant have to be? It has to be 2. So do you agree that my velocity would be 6t squared plus 2? Because in this case, again, they said if t is 0, the velocity is 2. So I'm going to add that 2 as my constant. And then at time t equals 0, the position is going to be 5. So, and how do I get to position from velocity? If you integrate velocity or integrate f prime, if I integrate velocity, I'm going to get position. So the antiderivative of 6t squared would be 6t to the third over 3 plus 2t plus a constant. This is going to get me my position. And again, they said at t equals 0, the position is 5. Well, if t was 0 here, we've got 0 plus 0. We need to get 5, so my constant in this case is going to be a 5. So we've got, instead of 6t cubed over 3, I'd go ahead and say we got 2t cubed plus 2t plus 5. I see that in answer D. This question is asking if my function is continuous and differentiable. It's asking about continuity and differentiability. So for a function to be continuous, as I approach a value from the left, let's say I'm approaching 5, because in this case we are. As I'm approaching 5 from the left, the function has to approach the same value as if I approach it from the right. So what that means is when I approach negative x squared plus 3, that has to equal negative 10x plus 28 at 5. So when I plug in a 5 for my x, I've got negative 25 plus 3 is negative 22. And I'd have negative 50 plus 28, what do you know, is also negative 22. So it is definitely continuous. So I like A and B. I do not like C, and I do not like D. For something to be differentiable, that means that the slope from the left has to be equal to the slope from the right as I approach 5. And we can have no cusps or corners. So in order to check that, I'm going to say, all right, what is my slope of my function? And I'm going to put that here. F prime of x would be the derivative of the top would be negative 2x. The derivative of the bottom would be negative 10. The question is, what is the slope when x is 5? Negative 2 times 5 is negative 10. Negative 10, I cannot substitute in a 5 there, but my left side slope is equal to my right side slope. Therefore, my function is continuous and differentiable. Answer A. 16 is they gave you the derivative and they want the function. And if I've been given dy dx and I want y, I need to integrate. So this is exactly what we did in chapter 7. This is a differential equation rather. And the first step is to always separate our variables. We've not had one like this because I cannot just add y to the left side because we cannot take an antiderivative of y plus dy dx. It doesn't work that way. Dy dx needs to be multiplied by whatever our function is on that left side. So if I cannot add the y over, I need to take that entire quantity and divide it over. So I'd have 1 over 2 minus y dy. I'm going to multiply my dx to the right side. That was left with a 1, and I'd have equals dx. And again, what I've done right here is I've taken 2 minus y, I've divided it from both sides, leaving me with the following. Okay, in order to take this and find the actual function, I'm going to take an antiderivative. Get out of my way. And the antiderivative, I'm going to start with the right side. The antiderivative of 1 dx would be x plus c. And then the antiderivative of the left side is going to be a natural log of 2 minus y. But be careful, is the derivative of natural log of 2 minus y 1 over 2 minus y, but because I have a negative variable, I'd have an extra chain rule of a negative 1, so I need to counteract that, and I'd have a negative natural log of 2 minus y on the left. I'm going to go ahead and let's go ahead and get my y by itself. So I would before I both sides, I would divide out my negative 1. So I'd have the natural log of 2 minus y equals negative x plus c. And again, you could write minus c. A negative constant is still a constant. I'm going to both sides, and I'm left with 2 minus y equals e to the negative x plus c. Therefore, if I move some things around, I'd have a y equals 2 minus e to the negative x plus c. At this point, I'm going to go ahead and plug in the point that they gave me. They gave me the point x is 1, y is 1. So I'm going to go plug that in. X is 1, y is 1, 2 minus e to the negative 1 plus c. I'm going to move my e over. So I'd have e to the negative 1 plus c equals 2 minus 1 is 1. I'm going to natural log both sides. So I'd have negative 1 plus c is the natural log of 1. The natural log of 1 that I hope we remember is 0. Therefore, c is 1. When I go plug that back into my y equals equation, that looks a lot like answer B. All right, a point of inflection is when the second derivative changes signs. We only have the function, and in order to get the second derivative, I'm going to say g prime, the derivative of the left, is going to equal the derivative of the right. When you take a derivative of an integral, they cancel out, and I'm left with the function with respect to my upper bound. So I've got x squared minus 5x minus 14. You might be saying, oh, I don't remember this. Well, let's remind ourselves. Derivatives and integrals cancel each other out. We should then always plug in our upper bound, technically times the derivative of my upper bound, and in this case it'd be 1, minus plugging in my lower bound, times the derivative of my lower bound. Because my lower bound is a constant, the derivative of the constant is 0, and all of this would turn into 0 anyway, so we don't have to worry about it. Okie dokie. So that's the first derivative. A point of inflection, again, is when the second derivative changes signs. So g double prime would be 2x minus 5. Again, to figure out where those critical numbers, about where this could potentially change signs, we've got to take that second derivative, find out when it's equal to 0 and or undefined. The line 2x minus 5 is never undefined. It is equal to 0 at 5 halves, though. So I'm going to go back to a sign chart. We've got 5 halves. I'm going to plug in a number smaller and bigger. Those are x values. We're going to plug them into the second derivative to tell us what's going on with the function. If I plug in 0 to my second derivative, my second derivative would be negative, therefore my function would be concave down. If I plug in 10 to my second derivative, I'd get 2 times 10 minus 5, which is positive, concave up, therefore there is a point of inflection at 5/2. This is a big chain rule question again, derivative rules. What we have here, I would even rewrite my original to remember that this is a chain rule and the product rule. Whoa, x cubed times the secant of 2x. We have one function. We have one function here. We have another function here. This is going to be the product rule. This is a derivative rule of the product rule. And to remind ourselves what the product rule is, that is f prime times g plus g prime times f. Okay, in this case, f is going to be my x cubed and secant of 2x will be my g. We also call this one fig plus gif. All right, let's go find f prime. F prime is going to be 3x squared. You leave your g, secant of 2x. F prime times g, we got f prime times g. Plus, then we got to go do g prime. Ooh, the derivative of secant. Can you remember that it is secant of my angle, tangent of my angle, times the derivative of my angle. So times 2, this right here is all g prime. We got to make sure that we multiply that times our f, and our f was x cubed. If you take some time to figure out what answer that looks like, we've got a 2x cubed secant tangent. Yep, this is looking like D. They just put it in opposite order. All right, if we're trying to figure out, where is my particle moving? If it has a negative velocity, it's moving to the left or down in this case. If it has a positive velocity, it'd be moving right or up in this case. So let's go ahead and find my velocity. Velocity would be y prime. My y prime of t is 3t squared minus 8t plus 4. My velocity at the time that they ask, at 1, when t is 1, would be 3 minus 8 plus 4, would be negative 5 plus 4 is negative 1. Because my velocity is negative, we know that the particle is moving down, so we can get rid of C and D. Okay, then if we're talking about, is my velocity increasing or decreasing, that's really asking about the acceleration. So we've got to go find my acceleration. So y double prime of t is 6t minus 8. At this time, when t is 1, we'd have 6 minus 8, which is negative 2. Because that is a negative value, we know that the velocity is decreasing, therefore answer A. All right, guys, this goes back to integration rules. If I know the area of f from 1 to 4 is 8, and the area of function g from 1 to 4 is negative 2, that's saying which of the following cannot be determined from the following info. Well, am I allowed to switch the bounds of g? I'm absolutely allowed to. That would mean that if I switch my bounds, my answer would be a positive 2. Am I allowed to take an area of my f function and multiply that area by 3? We are absolutely allowed to. That answer would be at 24, 3 times 8. And then I'm going to jump to D. In D, it's saying, hey, can you take that area that we just found in B, which was 24, and add G's area from 1 to 3, which was negative 2, and we are allowed to do that, giving us an area of 22. What we're not allowed to do is take areas and multiply them together, because again, this is saying take 3 times my F area, which is 8, times my G area, which is negative 2, which is going to get me a negative area, and so this rule obviously doesn't apply, because I'm multiplying areas together doesn't mean that my whole area would be negative. So we are not allowed to multiply together functions when all we know are their areas. This is not going to get us a true value. Oh boy, we're staring back at the formal definition of the derivative. This is before we knew derivative rules. So the formal definition of the derivative is the limit, as h approaches 0, of f of x plus h minus f of x all over h. And again, what this is asking is what is the function? 1, what is the function? And 2, therefore, what is the derivative? Okay, so we've got to go ahead and extract the function. Well, the function is what we're subtracting here. So my function is the sine of 2x. And since this is the formal definition of the derivative, you want to go ahead and take that derivative then. The derivative of sine is cosine of the angle. Notice that that's an answer, but it is not the answer. You cannot forget about chain rule. The derivative of my angle is 2, getting me answer D. All right, for this question, this is again dealing with chapter 7 with slope fields. And we've got to think, all right, what points do we want to plug in to check their slopes? So do you agree that the slopes when y is 0, or when x, oh no, those are not slopes, those are just the scale. Okay, when y is 0, the slopes are 0. Okay, so we could use the point, say, 2, 0, or when my y's are 0, my slope needs to be 0. So if my y is 0 here, is my slope always going to be 0? Yes. This does not influenced by my y's. So if I were to pick the point, say, 2, 0, that's going to give me a slope of 8. And at the point 2, 0, we know we have a slope of 0. So that cannot be B. If, again, my y is 0, my slope has to be 0, and this one will be influenced by the x-coordinate. So again, if you want to try the point 2, 0, that'd be the absolute value of 2 plus 0, which is 2, and we need a slope of 0. So I am liking C and D right now. I'm just going to pick an arbitrary point because one exponent is odd and one exponent is even. I'm going to go ahead and choose a point where both my x, if my y is negative, I'm going to go ahead and pick the point 2, -2. That slope here appears positive, and I just drew all over it, so let me show you. The point there at 2, -2 looks positive. If I were to plug in -2 and cube it here, a negative times a negative is a positive times a negative gets me a slope of -8. Obviously, my slope needs to be positive here, so it cannot be C. If I were to plug in the point 2, -2, again, because it's an even exponent, -2 squared gets me a positive slope. My answer is D. Okay, you're going to skip 23. That's volume. That's going to be 8.3. We're going to go to 24. On 24, it says the graph of a piecewise function f. We're given f. What is the value of the integral of f prime? This is the fundamental theorem of calculus. And to remind you what the fundamental theorem of calculus is, it says if you're given the velocity, if you integrate velocity, you're left with the function. And if I were to go ahead and say I was given an integral from a to b of f prime, we're left with the function because, again, derivatives and integrals cancel each other out, and I'd be left with the function with respect to my upper bound minus the function with respect to my lower bound. So this integral, because they let you know this is f prime, this is going to be the same. Again, the derivative and the integral cancel each other out, and I'm left with the function with respect to my upper bound minus the function with respect to my lower bound. I can go to my graph and find f of 12 is -4, f of 0 is +4, -4 minus 4 gets me -8. Okay, we have not seen a function or a question like this 25 yet, but we can use what we know and apply it and solve it. So it's saying that if we've got this function, y equals 2e to the 6x minus 5. Then if we applied that function and found its first derivative minus 6 times y, which is this quantity minus 30, that we want to get 0. We want to know which of these equations would it work out that when we plug in the derivative or the second derivative, that we would get 0 every time. So let's go ahead and first find what is the first derivative. The first derivative of e to the anything is going to be 2e to the 6x times the derivative of that exponent, which is 6. And then the derivative of minus 5 is going to be 0. So my first derivative is 12e to the 6x. My second derivative is going to be at 12e to the 6x times the derivative of my exponent, which is 6, getting me 72e to the 6x. And all it wants us to do is plug in this for y prime, this for y double prime, this for y, and see which of these equals 0 in the different equations that they got us. Let's start with the first one. My y prime is 12e to the 6x. Minus 6 times my y in this case is 2e to the 6x minus 5. Minus 30 needs to be equal to 0. Well, I'd have a 12e to the 6x minus 12e to the 6x, good start, plus 30 minus 30. Love it when the first one's my answer. We got A to work. I can teach you a less guess and check method when we're back. 26 is asking at what x value, at what x is the minimum occurring of this function? Well, you guys don't forget a minimum happens on a graph when the slope changes or when f prime changes from negative to positive. Okay, so the slope or f prime, we got to go find my first derivative. The derivative of 3x to the 4/3 would be 4x to the 1/3. 4/3 minus 3/3 is 1/3. The derivative of minus 2x will be minus 2. When is this ever equal to 0 or undefined? It's never going to be undefined because we aren't dividing by that variable. But it would be equal to 0 when 4x to the 1/3 equals 2, or when x to the 1/3 is a half. And since this is the x to the 1/3 or the cube root, we would then need to cube both sides to get my x by itself. 1/2 cubed is 1 cubed over 2 cubed, which is 1/8. That's my only answer, and since that's my only critical number. So technically, we should be checking this on our sign chart, but because I see that there's not an answer of there is no minimum, I feel pretty good about B if I had a time constraint on the test. But since I don't right now, I'm going to go ahead and plug in values, x values, into my first derivative to tell me what's going on with my function. If my x was 0 into my first derivative, I would have the quantity 0 minus 2, and I'd have, if my first derivative is negative, that means my function's decreasing. If then I have 4 times 1 minus 2, we'd have a first derivative that is positive. If my first derivative is positive, my function is increasing, and it's gone from negative slope to positive slope, so we have a minimum when x is 1/8. All right, 27 is asking us to interpret if W is already a rate. And they're talking about a storage tank emptying and then filling. It starts empty and then it begins filling with water. And they said W is the rate at which the depth of the water is increasing in feet per hour. And then they said, well, what is W prime of 2 is greater than 3 means? So 2 means is 2 hours after when we start. If we're starting at t equals 0, 2 hours after we start, we're talking about a rate of a rate because they want us to take the derivative that's already rate. So we're really talking about acceleration. And so if we look at our options, 2 hours after the tank begins filling with water, the rate at which the depth of the water is rising is increasing at a rate. We're really looking for the words rate of a rate. And it's saying that that rate is always going to be greater than 3. This is a helpful hint too, feet per hour per hour. We knew we were looking for acceleration. If W was feet per hour, W prime is going to have to be feet per hour, and C is my answer. The problem with A is it says, I like with it saying 2 hours after the tank begins filling, that's good. The depth of the water is increasing at a rate greater than 3. The problem is here, they're describing W, not W prime. We need a rate of a rate. B, over the first 2 hours after the tank begins filling, the depth of the water is always increasing at a rate greater than 3. Again, when we're plugging in that value, it's saying at this point in time, at 2 hours. So I don't like B, and again, I don't like that it's not talking about the acceleration or the feet per hours. And again, D is over the first 2 hours. The rate at which the depth of the water is always increasing at a rate greater than 3 feet per hour. What's the problem here? Again, they're not saying at 2 hours at that point in time. They're saying over that interval, when we're plugging in that value, that's saying at 2 hours, not during those first 2 hours willy-nilly. Okay, what we have here is a related rate. These are tough. They're really a plug and chug, but you might want to practice with the related rates extra problems that I've uploaded. We've got a person standing away from a balloon that is above the ground. The balloon is rising at a constant rate of 2 feet per second. So when I say related rates, we're talking about dy dx, dy dt, right? Rates over time. So I'm going to go ahead and call this the x-axis. This is the y-axis. I'm going to go ahead and call this the z. It says the balloon is rising at a rate of 2 feet per second. So y does not equal 2, but dy dt does equal 2. Positive 2 because the balloon is going up. What is the rate of change in radians of the angle theta? So they want d theta dt because they want that rate of change. This is what we're looking for. The instant when the balloon is 40 feet above point P. So that is when y is 40. Okay, so if I'm trying to find d theta dt, and I know that this side here is 30, constant. This is not changing. This is 30, and this is the adjacent side to theta. And I know at this point in time that they're asking about, my y is 40. So with relation to theta, that's opposite. This is adjacent. So I'm going to go ahead and say the tangent of angle theta equals the opposite, which is y, over 30. Because this 30 is not changing, I'm okay with putting it in. I cannot put in 40 for my y yet because 40 is not a constant. This balloon keeps rising and the person's probably crying that they lost the balloon. Okay, if I were to go, if I need d theta dt, that means that I need to take a derivative. The derivative of tangent is secant squared of my angle times the derivative of my angle is d theta dt. That is what we want. Because I'm taking the derivative of my y over 30, you could think of this as 1/30th y, and the derivative of that would be 1/30th. The derivative of y is dy dt. Now, if you didn't think about it as 1/30th y and you left it here, we'd have to do quotient rule. And if we did quotient rule, I'm going to walk you through that just in case you need it. The quotient rule derivative would be low d high minus high d low all over low. We're going to get the same answer, but man, this is a little bit more appealing to me than that craziness. But it's all the same. It really is. At this point, we're going to do a little plug and chug. Let's see if I can get some better colors out here. I don't even know how to do it. Nope. Nope. I don't remember. Okay, so we're going to just stick with these ugly colors. If we need to get the secant is the reciprocal of cosine. Cosine, I know, is adjacent over hypotenuse. So if I'm looking for the adjacent and the hypotenuse, I'm going to need to go ahead at this point in time, and I'm going to say, all right, this was 40. If this is 30, at this point in time, this is 40, 3, 4, 5, or a 30, 40, 50 triangle. Again, if the secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse, 30 50ths, the secant would be hypotenuse over adjacent, which is 50 30ths. So I'm going to have 50 30ths squared times d theta dt, that's what we want, equals 1/30th dy dt. They told us our dy dt was 2, so I'm going to go ahead and plug in a 2 there. We're going to get some algebra heavy numbers here. All right, so we've got 50 squared is going to be 2,500. 30 squared is going to be 900 d theta dt. 1/30th times 2 is 2/30ths or 1/15th. To get d theta dt by itself, I would need to divide by 2,500 900ths or multiply by the reciprocal. I'm going to go ahead and give myself some more room over here. And d theta dt is 1/15th times 900 2,500ths. Wow, this is ridiculous. Okay. Okay. So when we go to simplify this, we can easily just cross off 2 of my zeros. So I'm left with 1/15 times 9/25. That would get me 9/25 times 15 is 375. 9/375. I know 3 is going to go into them. 9 divided by 3 is 3. 325 divided by 3 is 125. Holy moly. This next question is honestly Algebra 1, Algebra 2, Pre-Calc. I don't remember how to erase these things. There we go. And we've covered this a bit in calculus as well. Vertical asymptotes are when my denominator equals 0. But be careful. When we go to factor this can be factored with difference of squares. So when I factor this, I'd have x squared plus 4, x squared minus 4. This can still be factored using difference of squares, and I'm left with x minus 2 over x squared plus 4 times x plus 2, x minus 2. So is there actually a vertical asymptote at this 2 when this denominator would be 0? We'll be careful because these are common factors. So what we know what's happening when x is 2 is a hole. There is a hole or a removable discontinuity wherever you have a hole. So these get canceled out. I'm left with the function 1 over x squared plus 4 times x plus 2. And now we've got to say, all right, where would these denominators equal 0? When is x squared plus 4 ever going to equal 0? That'd be when x squared is negative 4. And then I'd have to take the square root of negative 4, and we don't deal with imaginary numbers, so this is not going to create us a vertical asymptote. Obviously, anything squared is going to be positive, and when we add more positivity to it, it will never equal 0. So this is not going to give me a vertical asymptote. This will give me a vertical asymptote whenever x plus 2 is 0. So we will have a vertical asymptote at x is negative 2, which gives us 1 vertical asymptote. Lots of factoring in that one. Go and skip 30. We'll get back to that, and we're going to go